Now, should we have a look at evaluating a conceptual architecture? And of course, the first question is, well, what could we reasonably evaluate in a conceptual architecture? Fair question. Well, we can reasonably evaluate whether all the functionality that should be there can be supported. Now, this is both the expected functionality, the exception case functionality, and that's probably about it for the functionality. We can, to some extent, evaluate whether the non-functional characteristics can be supported as well. Not entirely, because some of those depend on exactly how we set up the execution of it, but some of the characteristics can be at least investigated. We're not able, obviously, to investigate any of the quality characteristics that depend on implementation details, because it's a long way from implementation, and the assumption is that the conceptual architecture assumes that no limitations. I mean, there's no implementation requirements present in the conceptual architecture, so we can't evaluate it too well. So let's look at what you should do right off the start. The first thing is, have the solid principles been applied? Now, these are not rules, they're not judgments, you shall not do these things. These are principles, these are guidelines, and you can reasonably have a look to see whether the proposed design conforms to the guidelines. Similarly, you can have a look at the grasp principles, and again, these are principles, these are guidelines. They're not irrevocable rules, they are there as guidelines, and you can check whether the design conforms to those guidelines, and if they don't, is there good reason why they don't. Now, when it comes to the functionality, the question is, will this model satisfy the business needs? Is it a good model of the solution? Can we investigate how well this particular model supports the business solution? So for that, we can trace the functionality of different functions through the system. Obviously, we should start with, does it do the obvious and the expected? I mean, it's not much use if it doesn't do the obvious and the expected. So take some of the very typical user narratives or use cases or use stories or whatever expression you have for the requirements, and trace that transaction through the system. You can do this either by drawing a line through the path of execution, or the equivalent, the original object-oriented design method proposed by Beck and Cunningham back in 1998 for object-oriented software design, or object-oriented programming, I think they had it at the time, where you passed a token around a collection of people sitting at a table, and each of those people represented a collection of classes, and the token represented who could actually speak, and they would speak to what their class was doing now, and hand off the token to somebody they had to call on for collaboration. Either way, you should be able to trace the path of execution of any particular transaction or any particular event through the system. And the note there is that this is a fairly rigorous kind of review, and with all reviews, rigor takes time. Now we know, after we've done that the architecture supports the expected conditions. Now, does it support the unexpected conditions? Now, by unexpected conditions, sort of unexpected is unexpected. Well, we're talking about the exception conditions, and we should reasonably look at those, because these are what occupy about 80% of the effort. It's not the normal case that matters, that we assume we can do. It's what happens when things get tricky. So there's some things that we can do. We have workflow exceptions, we have state transition exceptions, we have failure conditions, and we should have a look at, does the system support the responses to those things? Now, some of these failure conditions would be things like, say we're doing maintenance or something. We're this system is temporarily unavailable and yet there's demand on it. Do we cope with that? So we can go through some of the exception conditions and see whether it copes. Now they are the business exceptions. Okay, what about foreseeable stresses? Now this is a business system, and some of the stresses would be things like a web storm. If you've got a web-based transaction system, you don't control how many people log on or try to access the system at the same time. So what happens if you get a web storm? Now that's something that's reasonably foreseeable. You should be able to look at that. What about a hacker attack? This is reasonably foreseeable, if not inevitable, and you need to have a look at whether the architecture will support a response to a hacker attack. What about multiple simultaneous events? You may be able to control a web storm by load distribution and filtering the number of transactions each time. What happens if you get several simultaneous events? We're not overloading the system, we're simply having a whole lot of things happen at the same time. Does the architecture support handling that? How about exceptionally large data? If that's possible in your system and you've got, I don't know, maybe you're designing an architecture to deal with image processing or something of that nature, and you have built the system to cope with the size of images we have now. Well, the size of image we have now, if you have a look at what's going on in television, for example, your basic television is, what is it, 480 dots across the top. High definition is considered to be 720. Okay, higher than that is 1080. And we're getting up to 4K, and I hear that NHK, I think it is in Japan, are going to broadcast some sporting event at twice that, at 8K, so 8,000 dots across the top. If we're getting up to image resolutions of that nature, it's not going to stop there. So if you're dealing with an image processing system, you'd probably better think about can it handle exceptionally large data. You won't be able to predict exactly how big, but that is a foreseeable stress on the system. All right, so we've got these things. These are foreseeable stresses. The world around outside responds to it. What about foreseeable evolution? Now here we should think about in what way is the business process or business problem likely to evolve? And I can't answer that, but the business person should be able to answer that. How has business evolved in the past? Now, some of the evolutions would be to increase the number of transactions, to increase the complexity of transactions, to increase the number of customers, increase the spread of the market. These are foreseeable evolutions. We could also have an adaptation to a different business model. Here we have systems which might be used for one thing adapted to another thing because they're reasonably similar or because they do something reasonably well. I mean, the case study in Bass, Clements and Casman on a product line system where it was a control system for a naval ship, and among other things, it controlled the armaments and launching rockets and guns and things like that. Now, they adapted this system to an airfield by simply saying, well, it didn't move much, it was located in one place, and it didn't roll in the sea, so they didn't have to adjust the guns and they didn't have to do a whole bunch of things. But that was something that wouldn't have been predicted when you were building a control system for a naval vessel. So those are the checks that you can do for a conceptual architecture. As we go, first we check whether the solid principles and the grass principles have been adhered to. Then we can go through and check, is the expected functionality provided? Then we can check, is the exception conditions in the functionality, or the extreme functionality, is that supported and provided for as well? Then we can have a look at foreseeable architectural stresses, so changes in the business case or changes in the business model that we can foresee. Can that be taken care of? Then we can have a look at the potential evolution of the system and see whether that can be supported as well. So there you are. That's how you can evaluate a conceptual architecture.